polymorphism and virtual functions. That's what we were doing, and just a quick reminder, we made these definitions. There are virtual functions. The virtual functions, if they are called the right way, their meaning is decided during the runtime. That's why we say that they are late bound, okay? They are late binding functions as opposed to early binding functions, whose decision to which function to call is made during the compilation time, okay? And if we have a function, pure virtual function, which is a virtual function that doesn't get implemented, okay? If we have a class that includes a pure virtual function, we call that class an abstract class. An abstract class cannot have objects, of course. Other than that, it should include at least one pure virtual function. Up until this chapter, we have been writing concrete classes, okay? Not abstract classes, but concrete classes. So when we design software modules that includes lots of classes, we try to achieve something like this, okay? We say that these classes are somehow related, okay? They share some common code. So what we do is include that common code in the base class, okay? Put together all those code in the base class and drive from base class to specify your differences from the other classes. So that will make you understand your problem better, because you are organizing your classes based on your problem structure. That will make you understand it better, and that will lead to a nicely organized, maintainable, reusable software structure. Okay? You are going to see this maybe in 101, CSE 101. Maybe you saw it already. Software development is not just programming. You just don't code, okay? You understand the problem first, okay? You analyze the problem, you design your solution, and you implement it and you test it. Implementation takes maybe only 20% of your whole effort, right? Implementation is important, of course, but it is not the only thing in software engineering, okay? So analyzing the problem, designing your solution is more important than the implementation. If you start implementing your solution from the beginning immediately, you are going to fail miserably. Why? Because you don't have any plan. It's like trying to build a building without having a plan. And usually, if the building is small, maybe you can build a small Gecekondu maybe. But if the building is large, then you are not going to go far. You will end up starting your project from the beginning again. So these kind of techniques, using hierarchy structure, has a relationships, and designing them from the beginning is something that we try to do in software engineering. Of course, it is not possible to see this solution from the beginning, because, I mean, we are not that smart, right? Maybe if you are experienced, if you have been a software engineer for the last 10 years, maybe if you can see something, but it is not that easy to see the end of the final picture for your software. So what are we going to do? Maybe we are going to develop some prototypes first, okay? Some testing code. Testing code doesn't mean that our prototype code. It doesn't mean that it is the final code. You are writing code just to see if the ideas work, just to see if the things are working. So remember what I showed you about the Java collections hierarchy? So where did my, okay, Java collections. Remember this, I said that it is complicated, it is involved, and some people don't like it much because it is missing lots of stuff. Or okay, maybe just open this one. Okay, so they did not develop this hierarchy in overnight. Okay, they developed it, they didn't like it, they developed it again, they changed it, and some of them it could not be changed, but they came up with this solution, and we have been using it for the last 30 years, 25 years, I don't remember. So it is not developed overnight. Okay, so developing software takes iterations. After each iteration, you make improvements. That's why the only thing that doesn't change, the only rule that doesn't change in software development is rule of change. Okay, the idea is you are going to change whatever you are doing. Okay, if your software is alive, if somebody is using it, then you will end up changing it over and over again. So don't be afraid designing something primitive, then implement it, test it. It works somehow up to some degree, then you redesign it and you work on it and you work on it until your customer is satisfied or until you are satisfied. Okay, so I mean, I get this question a lot. How do I know that hierarchy is going to work? How do I know that there will be a problem with my hierarchy? Because after designing this, by the way, remember our case tools? What was the case tool? CASE, case tools. Computer case tools. Computer aided software engineering tools. Okay. If you give this hierarchy like this shape to those tools, okay, they will produce you a nice C++ code or Java code or C# code or whatever object-oriented programming language you are using. Or I'm not sure about this, but it can produce C code for you too. Remember, you can do object-oriented programming by yourself, okay, with any language, including the assembly language. The only thing is that you wouldn't get any help from the compiler because there would be no publics and privates and inheritance mechanism. But you can say that these are my public parts, these are my private parts. For the inheritance, what does the inheritance do? It copies all the shape code inside the circle code, right? That's what it does. So if you do that copying yourself, that's going to be lots of work. And that means that you are doing the object-oriented programming in some other language. So case tools will take this hierarchy, will produce you some code, and you are going to modify that code, of course. It cannot be 100% automatic. What I'm saying is that this kind of design, software design, is independent of your language that you are using. It either C or Java, doesn't matter. Okay, let's continue. I think we looked at this. Where is my... This doesn't work. What happened to it? It crashed. Okay. Where did I put my... Maybe this one? Yeah. Okay. So let's open this hierarchy again. Still not responding? Yeah, here it is. So our employee hierarchy, base class employee and others, and this was figure 12, 19, and I think this is what we did right here. Okay, so this for loop runs on this employee pointers, and this is a question for you. Okay, let's remember this one. This is a polymorphic call, right? Because remember, toString is a virtual function, right? And I am calling that virtual function through the base class's pointer. Okay. So to be able to run the virtual functions, you need to use either the pointer or a reference to a base class or any class. Okay, and the definition of base class changes from class to class. For example, the employee is the base class for the hourly employee, and I think commission employee is the base class for the commission plus base salary class. Okay, so the definition of what is the base class changes. So this is a polymorphic call, right? It's a polymorphic call. You remember this one, dynamic cast? Remember at the beginning of the semester I showed you static cast, which was very similar to what we have been doing in C. In C++, we have other than the dynamic cast, other than the static cast, there is a dynamic cast. This dynamic cast says that, well, employee pointer points to an employee class, but that employee class is a class hierarchy, right? It could be a salaried employee, hourly employee, or some other employee. I like to typecast this employee pointer to a base plus commission employee pointer. Can I do that? Okay, so your code tries that. If it is possible, if that object is really a base plus commission employee, then it would return you a null, a valid pointer. Okay, otherwise it returns a null. Say that I couldn't do this. If it is not null, then that means what? My right pointer is definitely pointing to a base plus commission employee object, right? That's why I can call this get base salary, and I can call this set base salary, right? Set base salary, etc. Okay, and remember what we said about this. This is class specific code. Maybe we don't like this piece of code because this piece of code is not generic, right? It depends on base plus commission employee structure. It depends on something that I have derived from my base class, right? That's what it does. It's not part of the generic code, but if you like to behave not generically but specifically, then you do this. You do this. Line 28 and line 43 is nice, okay, because they are supposed to work for any kind of employee driven classes, line 28 and 43. Okay, good. So let me continue on this code. Question for you. If I make this okay, instead of base class, let me do it this way. Okay, let me make this employee and okay, does this compile?
No.
Yes, no. How many yeses, how many no's? Yes. 1, 2, 3, 4, 5, 6. How many no's? 1 no. Why not? Doesn't look right?
No, it's not like that. I mean, employee is more generative than base plus commission employee.
If it doesn't compile, give me the line number.
33.
What?
33.
33. 33 doesn't, why not? There is a relationship, right?
Yes, but
Every base plus commission employee pointer is also an employee pointer, right? This one will return a base plus commission employee pointer, this one. The value of that pointer will be either null or a valid pointer, null, right? And since each base plus commission employee pointer is also an employee pointer, line 32 and 33 should be fine, no problem. Yes?
37 does not compile because of get base salary not part of employee.
How about 36? 36 is going to compile because it's a pointer, right? But when I come to 37, what does it say? The right pointer, I mean, if you are the compiler, you are compiling this line 37. The right pointer is an employee pointer, right? And it is trying to call this get base salary, okay, through the employee pointer get base salary. To be able to understand if this employee class has any get base salaries, I would go to employee.h. Employee.h doesn't seem to have any get base salary functions, right? So this will fail at line 37. You might say that, well, I made sure that the right pointer is pointing to a base plus commission employee. Yeah, that's true during the runtime, but during the compile time, I cannot know that. I mean, when I'm compiling this line, I am compiling this line. All I know is that the right pointer is pointing to an employee object, right? So I can only say that whatever you are calling as a function, it has to be part of this class employee, but this is not in the employee class. We didn't have this problem before because whatever we call as the virtual functions, this toString or earnings, they are part of the class employee. That's why you cannot have any problems with those. Okay, I mean, in case you are wondering, how come through this base pointer I can call the toString of hourly employee or base plus commission employee? Well, this is a virtual function, right? Called the right way, and toString is part of the employee class, and I override it in the base plus commission employee class, right? This is not like that, okay? This is get base salary is not part of the employee class, so compiler doesn't care if it is virtual, not virtual, doesn't matter. Okay, compiler says that, no, this is not going to happen. I cannot compile this. Okay, good. So to be able to compile this, okay, I need to erase it and I make it this. Good. So, I mean, the idea of polymorphism and the virtual functions and the abstract classes are nice, but you need to be able to apply all this knowledge to C++ syntax. Okay? Most of the difficulty that we are having in terms of syntax is because we are dealing with a compiler. Compilers produce static code, okay? Once you produce the code, it is fixed. You have to run it. Interpreters are not like that, right? The difference between compiler and interpreter compiles each line during the runtime, okay? It compiles this line, then it runs it, then it compiles this line, then runs it, compiles and run. That's why during the runtime, because there is no compile time for the interpreters, during the runtime you can do any flexibility that you can, okay? You can introduce a new variable. You can write, during the runtime, you can write a new function and run it. Okay, it is possible. And you can do stuff like you can call a function during your writing of the function. You don't know if that function exists or not, okay? That's why interpreters are very flexible, but they are also inefficient a little bit. Why? Because during the runtime, you have to do compilation and running at the same time. That's going to take some time, okay? and they are not. I mean, since they are doing it during the runtime, they cannot get as smart as some of the compiler features, right? They cannot get as smart as some of the compiler features, but they are a different world, okay? Since they are not that inefficient, they are kind of, because, I mean, most of the problems that we are going to have related to the syntax of the language is discovered by the compiler during the compilation time. For the interpreters, sometimes during your runtime, you might get syntax errors, okay, saying that I am going to run this, but this doesn't obey the rules of the language. Why didn't you tell me from the beginning? Well, I didn't know that because I didn't execute the code yet, okay? Interpreter usually discovers those problems during the runtime. Yes?
Which one is faster from line 27 to 41 for loop, or if we change employee employee pointer to in line 27 to for auto star employee pointer, which one is faster?
I don't understand. I didn't understand your question. You are trying to modify my loop to,
Yes.
to something else?
Yes.
You mean the classical loop?
In line 27, if we write auto star instead of employee star, what happens? It will be faster.
Instead of employee, you put an auto. This both employee and auto, it is resolved during compile time. I mean, runtime doesn't know that either you wrote an employee in there or auto in there.
I'm asking because of if we use auto, then we don't need to distinguish if it is, we don't need to dynamic casting, right?
No, you keep asking the same question. You don't listen. You ask the question, you don't listen to my answer. No. Auto is resolved during compile time, okay? Compile, when you put auto in there, it goes to this employee definition. What is the employee definition? Employee is an employee pointer, so it replaces that employee auto with an employee pointer. That's it. Okay? Okay, it is resolved during the compile time. This is not an interpreter. It doesn't happen during the runtime. Auto, don't think auto as a very smart thing to help you. It just simply looks at the definition of this employees. Okay, here I found the type. That's it. So why don't we use the type directly itself? Well, we could, but sometimes it is. Remember, I mean, there is an object inside this namespace, and there is a static data number inside this thing. Now, what is the type of cout? All stream, right? Sometimes I don't want to do it. It is inside std, right? So instead of saying std all stream, I just say auto something, right? So so it is a shortcut for not writing many things, not punching many keywords. Okay, let's move on. I have another loop, this one. Again, range-based for loop here, range for loop, employees, employee pointer. What is this? Type ID is a global function, okay? It returns an object of type class, okay? Well, its name is class, very unfortunate name. And inside that one, there is a function named name. Let's see the definition of this type ID. Go to C++ reference. Okay. Type ID is a this one, like the dynamic cast, static cast, or the size. Remember the size of operator? It's an operator. But did I say function? It's an operator, right? It's an operator. Okay. You ask question to type ID. What is the type of this thing? And it gives you the result. Type ID type, or type ID expression. Okay. And it returns, let's give, okay, can I call this, okay, so it returns an instance of this type info class, okay, it returns one of them, and inside this class I have this name and I have this, well, these are not, maybe you would understand this one and this one. Checks whether the objects refer to the same type. If two things have the same thing, right? That's the thing, but I think this one uses just the name. So when you say type ID something, and if you ask the name of it, it will tell you the name of the type. You can say, for example, you could say cout double A, cout type ID A. This will return you an instance of this class type info, okay, std type info, and I am going to ask the name of it. What's your name? So this will print double on the screen. So I think somebody was asking this some time ago. Can I get the type information about an object? Something like that. Yeah, so this is type ID is here. Type ID here is type of the object. I mean, this is stupid to ask. Why? Because you know already what A is, right? You compiled it, you typed it. Type of A is double. You know that. But in this case, I don't, right? Because each employee pointer might point to a different typed object. And type ID is going to return you the type. It could be either salaried employee, base plus commission employee, or commission employee, and etc. That's going to give me all those names one by one. Okay? Good. Any questions? I think I could have done it. I think I could have done this one as like, what is your type ID? In this if statement, I can say, what is your type ID of this employee pointer? If it is base plus commission employee, then what am I gonna do? Can we write it? Let's write it that way. Okay. I am going to do this, copy and paste it in here. I am going to modify this so that I am not going to use this dynamic cast thing. Comment it out. Do I need it? Do I need it? No. Because I don't need the dynamic cast. Okay, base plus commission employee pointer. Okay, so this is what I'm going to do. If type ID of the right pointer okay is the same as what? Is the same as type ID of base plus commission employee, right? Since this is an operator, I can do that kind of stuff. This is not a function. If it's a function, you can't send a type name to a function, right? Size of is an operator. I can send a type name to a size of operator, or cast, okay? Dynamic cast, static cast, whatever. So I am asking if these types are the same thing, then then what am I going to do? What am I going to do? I need to get the right pointer, and the right pointer has to be of type base plus commission, right? So what am I going to do now? I need to, what? Static cast, right? I mean, see, we are C programmers, actually, right? I mean, we are pretending to be C++ programmers. We are trying to be object-oriented programming guys, right? But deep inside, we are C programmers. That means what? We can do whatever we want, right? So, this is what I am going to do. I am going to get this. Oh, not private pointer. This is employee pointer. This is employee pointer. This is going to be employee pointer, right? Employee pointer is my loop. And here I am going to say okay, base plus commission employee. Okay, the right pointer is C type typecasting. Just force it. I don't care what you are going to do, how you are going to do it. Okay, just this is a pointer. It's the same thing. It's just simple address, right? So my right pointer is the same as employee pointer. I am typecasting it. Okay, then I continue with this one. So let me get rid of this too. So instead of using dynamic casting, I am using this type ID function. And type ID again will return an object of this type info. And type info has, okay, name. This hash code is something that you are going to understand when you, well, yeah, no. I will tell you what hash code is after I told you about Java. Okay, and I don't know I forgot what before. It checks whether the referred by preceded referred type and other type info object in the implementation defined order. Oh, okay, that's good. Implementation defined order. So you can compare your ancestors with yourself. Okay, this one has to be implemented before me so that I can derive from it. Implementation defined order. So this looks like this was there before C++ 11. See this one? Somebody introduced this not equal to thing, starting with C++ 99 maybe, and they realized a problem about it, operator not equal to, okay, and they removed it in C++ 20. I don't know the reason, I don't know the story, and what am I gonna do if I don't have not equal to, okay? Maybe we should read it from the documentation of C++ 20, see the reason why they did that, and what is the plan to use, what is suggested to use as a not equal to operator. So, see what this is what I am saying. Before starting using any new C++ standard, okay, maybe we should wait until that standard becomes real standard and everything is settled down. Okay? And since we are following textbooks shouldn't be changed from year to year, saying that I am canceling this chapter because this rule has changed and etc. No, we wait a little bit and we start using it. So it looks like we are getting late for using C++ 14. Starting next year maybe. At this department we are going to use maybe C++ 14, not 11. But not C++ 20 or 21. Yeah.
Is type ID part of the C++ language? Or a library?
No. Well, yeah. Well, type ID is an operator, yes. But remember the rules? You cannot make up new operators, right? Yeah. Size of, dynamic cast, static cast. There is a const cast, okay, another type of cast. Type ID, and these are all operators. And I am not sure if you are allowed to if you are allowed to overload type ID. Because since it's an operator, right? I am not sure if you are allowed to overload type ID. Good, let's go back. And yeah, that's the end of the... So what does it say? See this one, line 64. Question for you. Is line 64 a polymorphic call or late binding call or not early binding call? Line 64. So I am deleting my objects one by one because I have constructed them one by one using new, right? For every new there should be a delete.
Late.
Hocam dersteyim, acil mi?
Hayır hocam, tamam, sonra arayayım.
Teşekkürler.
It is late binding because we have to decide which object is coming.
Well, you wish that it was late binding. That's what you are saying. Is it late binding? He said that, yeah, well, it should be late binding because we don't know what kind of object is coming and we should call the proper destructor, right?
Yeah.
Not the base class's destructor. Yeah, that your wishes are very well intended, but your wishes is not the same as the grade that you're going to get the same from this class, right? So is this a late binding call or early binding call? Line 64. I spent 10 minutes on this yesterday. Okay, hint for you. Well, my hints doesn't work anyway, but I have to try. Okay, here is the hint.
Destructor is virtual.
The destructor is virtual, right? Destructor is virtual. I define the destructor virtual, so when the compiler compiles this line, it says that I don't know which destructor to call. Remember what we said? Destructors are not called by you, okay? It is called by the compiler. Destructor has to call some, the compiler has to call some destructor at line 64, but it doesn't know which destructor to call, right? It will make that decision during runtime depending on this employee pointer's pointed object. That's why we make the base classes destructors virtual, okay? It's important to make base classes destructors virtual. Otherwise, I mean, you would have a very serious problem with this line 64. Well, in this case, maybe not, because remember, all of our destructors are default destructors, right? I mean, this one is default. Namely, what does it do? It doesn't do anything. I am not deleting anything because I don't have any dynamically allocated stuff and etc. And neither rest of the class hierarchy. But it's a good behavior, it's a good practice to define the base classes destructor as virtual. Once it is virtual, it has to be virtual for all the other classes that derives it from there. Does this one have a destructor? Does one get this? Yeah. Destructor, but again, it's the default. Okay, good. Okay, let me go to my slides and let me continue on this.
Is it early binding or polymorphism?
Polymorphism, yeah. Did I say early binding? Well, okay, let me repeat. This destructor, okay, I am not calling the destructor directly, but I know that this line will call the destructor, but which destructor will be called will be decided during the runtime, not the compile time. So this is a polymorphic call, this is a late binding call. Okay. Let's go back and let's go to the class, the book's example. The book talks about a figures example, there is a shape class and that kind of stuff, and I am going to skip this one. The book's examples are not that good. Okay. And virtually we talk about virtual. I don't like this example either. I am going to skip it. Okay. Okay. So virtual functions, they are like surprising how it works. Compiler, I mean, doesn't know which function to call. During runtime, it is decided, etc. So this is actually how it works. Okay. Virtual functions implement late binding. We tell the compiler wait until the function is used in the program, and your code itself will decide the type of the object and will decide which function to call. Okay, and very important object-oriented programming principle. We say it is overridden. Remember, if you are redefining a virtual function, it is called overriding. Okay, override. Virtual function change overridden, non-virtual function changed, redefined. Overloading is completely different. Overloading, overriding, and redefining. Okay, overloading is the old meaning stays. I am adding a new meaning. Okay, overload. Redefine is I don't like whatever I am having from the base class. I am going to redefine it. Override is, well, this function is a virtual function. I am going to override it, redefine it, so that it can be called properly during runtime. Override keyword, we already see that, okay? There is a sale class, base class, and there is a discount sale derived from the base class, okay? And we are saying that this bill is a virtual function, and I am overriding it. You don't have to repeat this virtual keyword here, but it would be nice to repeat it. This bill is definitely a virtual function, okay? This bill is definitely a virtual function, and because in the base class this is virtual. So it is, I think it is better to put this virtual in front of it. Doesn't hurt. Putting it in the definition of the function, so that whenever your customer reads it, he or she knows that it's a virtual function. Well, I mean, you have this override keyword here anyways. They are going to understand it, but usually we put the virtual in there too. What happens if you put override at the end of a function which is not virtual? Okay, you are going to get a compiler error. You cannot make a function override, okay, if that function is a virtual function. That's why it is nice to use this override all the time. Makes it explicit that this function overrides bill in the sale class. C++ 11 keyword. Doesn't exist in C++ 99. Another nice keyword is the final, okay? With the final, you are saying that I have this virtual double bill, okay? Constant, nice. And it's a final function, okay? What does that mean? You cannot override it in the derived classes. You cannot override it in the derived classes. Well, it is weird, right? I mean, why would you make a virtual function final, cannot be overridden? That's the meaning of virtual function, right? I'm going to override it, and the compiler is going to make this decision during the runtime to see which function is being called. If I don't override it, why am I making it virtual? Yeah.
Does it work like this? For example, we have 3 class for 1 base class and 2 derived class. I can override it for the second class, but I don't want anyone to override it again for.
Exactly. Yeah. Mm-hmm. You understand what he's saying? Say that maybe this is the case, right? There is a hierarchy like this. Class A, there is a function, virtual function f, okay? Then I have class B. I am overriding this virtual function f, but I am making it final. And from afterwards, C or D, they cannot override it afterwards, right? So this might be the case. Rare case, but I mean, they made it possible. By the way, I think they have stolen this. I mean, Java is completely designed by looking at the C++ syntax, C++ structure, and they say that C++ is nice, but these features would have been nicer. Okay, so they tried to make C++ a nicer language. So for some part, yeah, they were successful, and finally something that was invented by Java. So C++ people got this final from Java, and they added it later to C++. That's why it is added in C++ 11. Okay, so I make this virtual function final. Yeah.
At C and D, does it become a non-virtual function?
What?
At class C and D function build, does it become a non-virtual?
No, definitely no. It is still virtual, but you cannot override it. So if you call this bill on an object of C through a pointer to B or A, it will be late bound. It doesn't become non-virtual. It is still virtual, but you cannot override it. So this one will give you a compiler error. Okay, good. Okay. Since virtual functions are so nice, why not use it everywhere? Everybody, okay, become virtual function. Your meaning will be decided during the runtime and etc. Well, that's what Java does actually. Java for everything. In Java there is no virtual keyword. All the functions are virtual. Okay. If you want to make them non-virtual, either you make them static or private or something else. So being non-virtual is something that you need to specify. Everything is virtual in Java, all the functions, other than the exceptions. Okay. So, well, I mean, the main philosophy of Java and C++ are different. C++ is extension of C. We think about efficiency, we think about memory usage, etc. Java says that, okay, we are fast enough. I can spend maybe 5% of my CPU time for deciding which function to call. Okay, so the definite is flexible, but on the side there is an overhead. Okay, it uses more storage. Okay, you need to keep all that function names and etc. somewhere. Also, it is during the runtime. Late binding is making our programs slower. Okay, and you can see this. You can see this by, remember my favorite website, Compiler Explorer. Did I make any? Yeah. I think I use this virtual without telling you anything, right? So whenever you write a class with virtual keyword in it, okay, and let's make some, can I make this smaller a little bit? Yeah, I think I can. Still visible. Okay, integer main. And ABC, ABCA. Is it compiling? Yeah. Okay. So at the end of this program, there will be a function 2, function 3. Okay. At the end of this program, okay, there will be a table of virtual functions for this class. ABC is my class name. Okay. Function 1 and function 2 will be in this table. Okay. And that's called the virtual function table. And if you have virtual functions in your class, you have to have this virtual function table so that whenever I find you through the pointer, I am going to go to your table and pick the right function. These are function pointers actually. And if I drive a new class out of this one, that one is going to have A, B, C, D. Will have its own virtual function table. Okay. This is ABC. This is ABC. Where is my virtual function table for ABC? Well, since I didn't have any objects of it, let me make an object of it. Compiler is smart. If you don't make an object of it, then nobody uses that anyway. I am not going to do anything on it. Yeah, this is ABC's virtual function table. This is ABCD's virtual function table. So each class, not each object, each class has its own virtual function table. Whenever I make a polymorphic call, okay, through a pointer or a reference, I follow that pointer, I find the object, and I ask the object, where is your virtual function table? It says that my virtual function table is here, and I go to that virtual function table, and I find this function. Function 1 is here. I get the pointer, and I call that function. So following the pointer, making a lookup in the table, getting the pointer of the function and calling it. So 2 or 3 more steps than the regular, compared to the regular function calls. All I am saying that this is expensive. Why are you looking at me like that, okay? It's expensive. Okay, maybe 10 minutes of break will help you to look different. 10 minutes.
Type ID bir obje döndürüyor ya bana.
Evet, type info'nun objesini döndürüyor. Type info diye bir class var, onu döndürüyor.
O zaman onun daha kitap bilgim oldum. Sen ne kadar süre kalıyor hayatta?
Ne?
Tüm program çalıştığında hayatta mı kalıyor? Type info objesi.
Yok ya, sanki sana bir şey göndermedik, return etmedik mi hiç? Ne diyeyim, operatör artı yaptığında money için sana bir tane money return etmiyor muydu?
Tam ediyor.
Bu da aynısı işte.
Yok tam bir şey değil. Onun yaşam süresine kalıyor. Tüm
Dynamic
program
değil ki o. Copy yapıyorsun onu. Bir tane type info objesi return ediyor. Sen onu bir yere kopyalayabilirsin ya da o anda kullandın, attın gitti.
Yani
Ha, bir
o
money
adresin
return
aslında-
edildiği zaman sen money'i ne yapıyorsun? Artı operatörü bir money return ediyor değil mi?
Evet, tamam.
Bir yere assignment'ı atarsan atarsın. Atamazsan öbür gider. Onunla aynı.
Çizme var. Şeyde mi görüyorsun?
Onlar sınav soruları bir de. Onlar sınav soruları. Hangisini yapıyorsan. Kafasını falan. Yani yazıyorsun.
Altına raf kağıdı mı?
Herhalde onlar da neyden finalini doğru. Nasıl yapıyorsun? Polimorfik.
Zar diyorlar gerçekten zar mı?
Polimorfik olacak. Rantarda böyle. 6 arasında olacak yani. Mesela bir gelme ihtimali olacak mı? İlk deneye gelse hemen 2 tane 3 tane
Hepsine
para.
rastgele demiş diye biliyorum da yani sonlardan seçiyorlar işte. Böyle bir şey söz konusu zar atma.
Tam da zarar.
Ağırlığı yüksek yaparlar. Ama adil olmaz ya.
Bundan. Yap. Şey dedim mi? Chainsaw sohbet dedim. Oğlum acayip şeyler oluyor yani.
Bilmem ya.
Tahmin etmem.
Anime mi söylüyor?
Burada şey yani. Ben de küçük değerlerim bakın. Evet şu kabanı giyiyorsun eyvallah da kanka yürüyüşünü ver yani. Yanlış anlayabilirler.
Ne? Kim?
Bir tane kaban, şu kabanı gel. Kaban. Çok bir şey var.
Bugün biraz çıkaracağım. Aralarında bakalım böyle konuşabilecek.
Kardeşim ben gördüğümü söylüyorum. Sen dikkat et.
Simülasyon varsa gösterelim.
Simülasyon mu var kanka?
Bu yollar var.
Yaptın mı?
Hayır. Bir tane yedim.
Geçen haftakini yapıyoruz doğru.
Ben de yaptım.
Herkes yaptık mı abi? Herkes yapmadı mı geçen?
Herkes yapmalı derken nasıl yani?
Sen geçen hafta yapmadın mı? Laba girmedin. İptal olmadı.
Yok.
Niye yapsın abi lab yok? Değil mi?
Ha, doğru. Ne zaman söylenmişti? Akşamından mı söylenmişti?
10 dakika kaldı.
Sabah 1:30.
Sen yapmışsın gece.
Bugün deprem olsaydı ya.
Yani gerçekten bazen sadece deprem olması istersin.
Her gün deprem oluyor.
Mehmet'in genel bir lafı var hatırlıyor musun? Her cuma kar yağsın, laf işler olsun dedi. Sonra laflar arka arka olunca da
O kondansatör arasına voltmetre mi bağladınız? Başka bir şey var mı? Osiloskopun ismi.
osiloskop.
Osiloskop.
Voltmetre koyuyorsun oralara. Voltmetrenin grafiğini çiziyorsun. Direkt osiloskop bağlama. Osiloskop böyle yapıyorsun.
Evet, onu çalıştırdığında onu yapıyor mu? Devreyi çalıştırdığında ne
Ama
yapıyor?
neymiş ama?
Bir tane mi?
Bunların skillleri var. Çok iyi lan.
Ama sıkıntı var lab kağıdında. Şöyle
Bölümde çok iyi. Güzel çiziyorlar.
X5 ile artı 5 arası gitsin diyor. Ama 0 olmuş. Fark etmiyor galiba ama.
Ney sıfırlıyor yapmış?
X5 voltla artı 5 volt arası gitsin diyor. Sonra grafikçi zaten 0 olmaması.
Çok yaptık ya.
Grafik mi çizmiş? Ha, orada grafikler var ya, bizim çizmemizi istemiyoruz.
Ben grafik çiziyorum. İki devre çizmiş. İki devre var.
Referans devre varsa
Normalde uygun mesela. Yani o kaynağı şu 0 olmak diyor.
TR4 artı falan var mı yani?
Neler?
TR4 artı falan.
Ben derse geç mi kaldım?
Hatırladım da dert yazan
Kaça bir nasıl gidiyor mu?
Nasıl koydun?
Sen direncin de mi solunu sağlam?
direncin de solunu sağlam attın.
Direnci de öyle. Bak şimdi çalıştır diyorsun.
Değişik mi?
Geçen hafta değişti oğlum. Korkutma.
Bilmiyorum lan.
Ben de bilmiyorum.
Oğlum bizimkiler yurtta mı? Aldık ama.
Oo. 6 tane şey yaptım. 6'sı da ölçüyor. Tekini kalan falan.
Niye 10 tane şey var oğlum?
Hiçbir şey yapmama gerek kalmamış.
6 tane şey ölçüyor. 6 tane
Ben bir tane
Hayır ama 6 tane ölçüyor. Üçer
Ne
üçer.
ölçeceksin abi?
Üçer ölçüyor.
Ne ölçeceksin? Ne ölçeceksin? Ne oğlum? Ne ölçeceksin?
Bak her birine voltaj, her birine direnç, her birine
Evet daha
kapasitör.
finalde iyi yapacağını biliyorsun.
2 tane var. 3 çarpı 2 6. Onu da yaptın da.
Ya bunları bir tane yap.
Yapmamışsın bu.
Ya anlat anlat. Bir şey derdi öyle böyle de yok. Şu alttan ne var alttan? Alttan. Benim...
Saydı mı az önce?
Kardeşim göster ben anlamıyorum. Havada
Saydı mı az önce? Devrede var, voltmetre var.
Teknesinde devre
Direnç var, kapasitör var. Her birine ölçüyor.
Ben bir tane volt şey koydum. Bir tane ölçmüş.
2 devre var ama.
İki
Devre olunca güçlüyor yani.
Hocam bak
Açsana dedi.
devre şu.
Tamam. Tamam ben de bunu yaptım. Evet.
Volt kaynağı, direnç, kapasitör.
Sen
Her
ben
birine
de bir tane işte volt şey koydum.
hepsini ölçemez. Hatta dirence bakmış, kaynağa bakmış.
Kaynağı volt saat. Kaynağı volt saat.
Şu anda değil. Yani aynı.
Çorabı adına.
Belki üçünü ölçmemiz istemiyor. Üçünü ölçmemiz istemiyor.
İkileri şu daha büyüyor da ben göremiyorum.
Uyumuş yani.
Hayır.
2 kilo var. Geriye başlıyor.
Şu mavi kırmızı abi aynı şey mi?
Yok. Şey referans. Referans. Koy. Gri falan oluyor.
Anlaşılır içerik var.
Buradaki potansiyelleri düşünüyorum. Potansiyelleri. Bunlar potansiyelleri düşünüyorum.
Bu mavi, bu ile bunun arası. Bununla bunun arası. Bununla bunun arası. Buna basıyorsun. V eksi var. O referans. Bu V'yi koyduğun gibi referans bir yere koyuyorsun. Kere voltla
Biraz şey. Peki bu voltajı zamana göre değişmesi lazım. Bu nasıl? Kaynağı nasıl?
Kulak voltajı seçiyorsun. Şöyle olmalı. Ona 10 yazısı falan var. Sonra 5 yazısı da var. Ben burada şey
Frekansı nasıl kırmıştım?
volt. 5 volt deyince 0 voltla 5 volt arası değişiyor. Frekans bir frekans veriyorsun. Başka bir şey değişmiyor. Başka yanlar da var. İşte 0 ile 5 arası gidiyor. Pardon, eksi 5'te 0 ile 10 arası gidiyordu. Evet. DC ile ben bunu 5 aşağı çektim böyle.
Yani değilse şey
Eksi
pahalı.
5 artı 5 olsun.
Kayıt aldım.
Bunu koymuş ya. O 10 oldu. Hocam güzel. 10. 100 nano falan.
Daha karışmış ya.
Ama bak 3 şey var. Bu şeylere bakmışsın. Yazı var, kafam karışmıştır. Evet. Volt kaynağı, direnç,
Bu var. Bak
bu full devre.
her birinde potansiyel farkı var.
Kilidi
Ona ayrı
kullanmadım
var.
hiç.
Devre 3 eleman.
Tamam ya.
Hiç kullanmadım.
Bunda da aynı devre var.
Matematiksel şey biliyorsunuz ya.
Ben kullanıyorum.
Orada şeyin geliş formülünü
Daha
hesaplamıştı.
sonra getir.
O zaman sabit.
Soruyor.
Kağıtta neyi hesaplamamızı istiyor var mı? Başka bir şey. Zaman sabit.
TM hesaplamanı istiyor. Robotlar başkalar devre içinde başka istemiyor. Burada çift değeri varmış. Nasıl herkes biliyor? Bak tek sen biliyorsun, millet ısıtılmış.
Burada
Bir şey olmaz.
karda içi karda yoksa var.
Karda var.
Şey, karda mı?
Karda 25 kuruş atıyor.
Bir şey olmaz onu geçiş.
O da mı yalan? O da mı yalan?
Açtığımdan ya.
Attın mı?
Atıyor ama atmıyor. Sana işte sen atmamı demeyecek.
Enes,
Tabii ya, atma.
Enes sen bu mu oynadın? Niye kabul etmedin? İzleyici.
Ha bir yayın açıldı.
Kanka çatışmadaydım valla.
Ayıp.
İçinden gelişiyor.
Ben geçmiyorum.
Hangi oyunu kaç yılda çıkardın?
Onu bile en düşük ayarlar.
Diğer çok performans bayağı yüksek dedi.
2017 çıkışlı yaptı. 2016 oyun 2016
Hangi
çıkışlı.
çok güzel mi?
En düşük ayarda 1080 oynayamıyor.
1080 oynamadan.
En düşük ayarda. Aynı kadar kapasitedeyim. O zaman en iyi laptoplar. Bin serisinden sonra bayağı iyi.
Oğlum Bin serisi 2016'da çıktı. Nasıl Bin serisi 2016'da çıktı.
Bir serisi bayağı eski lan.
Kaç yıldır?
Binden 1000 yok bende.
Var da oğlum.
Seneden aldım.
Serisi yok.
Seneden aldım. Seneden aldım.
2017 aldım da 1 veya 2016 mı? Ben şey yaptım yok bine. Mobilde yok. Laptop yok. Laptop yoktu bine.
2016'nın sonunda çıktı.
GNU var ya. GNU slash
1080
Laptop'taki önemli işte.
doğru diyor. Laptop'taki farkı olsun.
Laptop'ta 1050 Ti var.
Tabii oğlum hikaye.
1060'da var da orada çok sorun çıkıyor.
1060 canavar yani. 1060 1052'ye kadar. Sana 950 mi var?
150 MB var. Yani performans da olsun.
950 M. TI mi?
Bunda TI yok. MX olabiliyor. Overclock. Benim serisinde oluyor yani.
Bildiğin baskıyı falan bir mantığı yapmış. Orada bir gaza geldim.
Bir sene
Sarmaz.
Lan oğlum çok mantıklı soru. Yok kanka birebir oyun. Sen olsun. Minecraft oynuyor. Oğlum adam göremiyorsun. Geniş haritası var. Baktık adam
Bende de var.
Her gördüğünüz rastörde beni biliyorsan. Aç o nerede? Mikrofon. Bacağı var diye. Bak içinden hemen geldi. Başka bir şey tamam hiçbir şeyle kapatırsan.
Okay, so the virtual functions, we like them, but they are expensive to use in terms of memory and in terms of CPU time. So we should be careful about them. We talked about pure virtual functions, like this one. A virtual function, but pure virtual what? I don't know how to implement it. I mean, either I am going to implement it in a stupid way, exit -1, or return something stupid. It is better not to implement them. But if you don't implement them, the compiler will object. And you are saying that compiler don't object to this. I am not going to implement this virtual function. Okay? So this class is going to be abstract. You are not going to make any objects of this class. The only purpose for this class, an abstract class, is to serve as a base class in a class hierarchy. Abstract base classes. So that's the meaning of abstract class. I mean, you make an abstract class just to make it a base class, right? So abstract class by itself without any hierarchy doesn't make much sense. By the way, if we go to the Java collections again, let's go to this one. Visit. Okay, yeah. So these are concrete classes, stack, vector, array list, etc. Okay. These are abstract classes, meaning there is a pure virtual function in them. Okay. And these are interfaces. Interfaces are special abstract classes in which no function is implemented. Okay. So everything in this one is an pure virtual function. You may think it like that way. Java makes a distinction between an abstract class and an interface. For C++, if you don't implement any of the functions in your class, you are still an abstract class. You are nothing special. But in Java, they call it in a different way. They say that, okay, it's an interface. Interfaces cannot have any implementations in them. That's why their colors and shapes are different. And they say that whenever you are writing a program, okay, don't use linked lists or abstract lists in your program. Use a list or set or queue. Okay. If you use set in your program, for example, you are writing a function. Your function should take as a parameter a set or list or queue. Okay. So if you take a set as a parameter, as a pointer, as a reference, then you cannot be dependent on any implementations, right? Because you are not using a class that includes some kind of an implementation. That's the idea. That's the idea of saying, remember what we said, write your code against the interfaces. So try to use something from the higher levels, iterable. That's the best thing, because at the highest level, it has the least amount of detail in it. It is very simple. So since you are not using very complicated stuff in your function, in your new classes, then you are going to stay simple. At least your interface is going to be simple. Always try to pick something at the higher levels, not at the lower levels. Okay. If I start using this tree set directly, then I am dependent on it. I am dependent on the idea of using trees in a set implementation. I am dependent on any bugs that you may have in this tree set class, right? Okay, good. Any questions so far? Could you turn that computer off? Turn the computer off. And you too? Turn the computer off. Okay, good. So abstract-based classes are something like that, and we will talk about these abstract-based classes a lot. And the libraries that I'm going to show you, can I show that to you now? Can I show that to you? JFrame library. Okay, Java GUI libraries. Okay, so, and this is Java graphical user interface libraries. They have developed this way. This one is directly from Java itself, but the rest of them are all, this is, see, there is a relationship and has a relationship between these two classes. Okay. And as you see, I think these are all abstract, these are concrete. Well, what is non-container components? Above the commonly used components are orange, okay. No, they are, well, They are all concrete. Color doesn't mean anything about the concreteness or anything like that. Okay, and there are many more. So we will be, what I'm saying is we will be using hierarchies, we will be using polymorphism a lot in our analysis of Java hierarchies and etc. By the way, let me show you the C++ string class hierarchy. That it? No. Well, I think I'm going, well, I have seen it in this one. Let me, okay. String library. Yeah, string is this. This is basic string. Couldn't find the string hierarchy, but string has an hierarchy. Well, I think I will talk about this when we talk about the templates. Okay, abstract base classes, I talked about it. Yeah, extended type. Well, is a relationship is something nice. Let's look at this problem. Let's look at this problem. I am going to delete whatever the book says. Let's write this hierarchy. Let's say I have a person class. Okay, as the data members, I have the name of the person, string. What else? I have the TC kimlik numarası of the person. And I have the setters and getters. Set, get, whatever, person. Okay, and I am going to derive a new class out of this one. Let's say I have worker class, employee class, whatever, or maybe student. Okay, student is a definitely, and there is an is a relationship, right? Definitely an is a person, but on top of the person, I have some specific information such as GPA, right? Student has a GPA, and student has the school name, right? String. And plus setters and getters for the new data members. Okay, I have such small hierarchy, person and student, and I know that there is a relationship in there. Let me try to make this a little bit smaller so that I can fit. Good. So I have a person P and I have a person pointer PP, okay, person pointer, student S, and student pointer. So what do I see in the memory? A person is here. Inside a person there is the name and the social security number. Okay, this is P. Let me make this address of P, and my pointer will point to this location, no problem. And for S, I have a person in it, right? name, TCK, and I have the GPA and the school, right? This is S, and SP is pointing to S, like that. Good. Okay, so far so good. Let's do some assignment stuff, okay, using the ISA relationship. Okay, can I do this? Can I make this assignment? A person pointer PP2 gets the value of SP. Can I do this? A student pointer, okay, is actually a person pointer too. So I can make this assignment. So the picture is going to look like this, right? PP2 will be pointing to the same location as this one. No problem, right? No problem. Can I do this then? Can I do this? I know that this is possible. Cout SP arrow get GPA, right? I can do this, no problem. This is okay. How about this one? Cout PP2 get GPA. Can I write this? They are pointing to the same object.
No.
The answer is simply no. Why? The compiler thinks about this object type, right? What is PP2 type? It's a person pointer. Where is the person class? Person class is here. Is there something like get, set, GPA? No. So I am not going to compile this. Doesn't make much sense, right? I know that where I am pointing to is a student object, and students has GPA, but the compiler doesn't let me do that. Well, the compiler can't, because all the compiler says is this PP2, right? Which is person. So if you like to get the GPA of this object out of this place, then you need to dynamic cast this PP2 to a student class, right? Then use it that way, or using the type ID and that kind of stuff, or you can force it. You can force it that way. Okay, you can force it that way. So this is something that we need to be careful about. So this always going this way, upcasting. This is called upcasting. Okay, this one is green is upcasting. Upcasting is always okay. I can upcast. Downcasting the other way, coming from this direction to this direction, is not always possible. Sometimes possible. Okay, when you need to downcast something, you need to use this dynamic cast operator. Okay, or type ID thing. Well, as I said before, we are C programmers, and I can do this, and this will compile too. Let me compile it. Okay, cout employee pointer. I am going to typecast it to base plus commission employee. Okay, force it. Okay, now it's a base plus commission employee. I forced it, and I am going to say get salary. Okay. Would this compile? Yeah. I'm going to tell you, yeah, this will compile. Okay. So I am going to make all the employee pointers to base plus commission employee pointer. Since it's a base plus commission employee pointer, I can now call get salary on it. Compiler will say yes, I will compile it. But what do you think I'm going to see on the screen as the salaries? Because some employees, for example, a commission employee doesn't have salary, okay? Or what, okay, no, it says get base salary. Let me fix it. Okay, get base salary. What am I gonna see on the screen? If the object I am pointing to is really a base plus commission employee, I am going to see this 5,000. If it is not, either I am going to see some junk numbers on the screen or my program will crash, right? I am asking to show me something that the object doesn't have, right? That's what I am trying to do. This is very similar to writing this integer a, its value is 7, double pointer dp gets the address of double pointer address of a and cout dp. What are you gonna see on the screen? What are you gonna see? 7.0? Really? No way. No way, no. What I am saying here is that I am not converting a integer to a double. I am converting a double integer pointer to a double pointer. So they are showing, okay, it's like, this is my memory again. A is here, in it there are 4 bytes, and in that 4 bytes there is 7, right? What kind of 7 is this? Okay, and there is this dp. dp is a pointer and it is pointing to this location, but dp thinks that that location is a double, so it assumes that there are 8 bytes in it, and it represents a double object. It represents a double object, right? So it's going to print either junk values or it's going to crash, because if that position is not if it doesn't belong to you, it's going to crash, right? It's exactly the same thing what we are doing here. What we are doing here is exactly the same thing, okay? So I am treating my object that I am pointing to as a base plus commission employee object, and I am asking the get base salary. This will compile and this will run, and probably it will print junk numbers on the screen, and sometimes it's going to crash. So you should not definitely do it. Of course, you should definitely test this to see what's going on, but definitely don't do this thinking that it's going to work from time to time, okay? So why am I talking about this? Similar stuff is happening here too, okay? If I can force it, if I like to force it, of course I am a C programmer, I am free to do anything that I like. I know what the compiler does, I know what it is producing, right? Even if it doesn't work, I will produce the assembly program, I modify the assembly program. I can get whatever I want. That's not the question. The question is staying within the boundaries of the object-oriented programming. Can I do this kind of stuff? So if you like to, if this PP2 and SP is pointing to the same location, through this I can get the GPA, but through this I cannot get the GPA. Okay? This is something not surprising. This is something expected. If you like to get the GPA of this object, then you should use either this SP or you should typecast this dynamic cast this to an SB student, okay, then use it. For that one, again, it is called downcasting. Downcasting is something that you need to be careful about, because is a relationship is always there, and you can use it. But the opposite of is a relationship, downcasting, it sometimes works, sometimes doesn't work. To see if it works, then you need to use the downcasting. Okay, so that's I didn't say anything new in this part. I just repeated what we know before. So let's do another experiment. Another person, P2, okay. Let's make that person here. Let's make that person. Since it's a person, it should have a location in the memory, and for the name and for the TJK there should be some space. And I am doing this assignment, okay, S. Let's say my name here is Ali, my TJK is 4471, okay, GPA and whatever. When I make this, can I make this assignment? The answer is this a downcasting or upcasting? Upcasting or downcasting? Upcasting. Why? Because this is lower in the hierarchy, as I am casting it to a, okay, up, okay, something this low, as this is up. This is upcasting, it should work, right? I am making this one, but what am I going to do? Maybe I can copy that name Ali here.
How it can
And 4471 there. But what am I going to do with this GPA and school name? Hold on. Okay?
It's not working. Okay.
What?
This assignment doesn't work because memory allocation space is different. P2.
What did I tell you? Hold on. Easy. Okay? I'll come to that. That's what I am talking about. Okay? So he's right. He just felt the problem. And the problem you are feeling is called slicing. Okay? That's what I am talking about. So I am making this assignment as to P2. Ali has a place to sit in. TJK has a place to sit in. But for GPA and the school name, there is no place to put in P2, right? What did I say? This is a relationship and I can do this assignment. Upcasting is okay. I didn't have this problem previously. Remember what I did? I assigned this as P2, PP2. Okay? I am pointing to the same object using two different pointer types, but I didn't lose any information. Now this one is losing information, and this is called slicing. Okay? Slicing is not a necessarily bad thing as long as you know what you are doing. Slicing happens, right? Slicing happens. If you do this kind of an assignment in the same hierarchy using the upcasting feature, is a relationship, slicing will happen, and don't think that all of your information is preserved in this assignment, because PT cannot hold this GPA and school name data members. Slicing happens. So if you are doing the direct object assignment, slicing will happen. But if you do the pointer assignment like this, slicing will not happen. But you cannot access that place, the GPA and the school name, through the base classes pointer.
If we make it type auto pointer, then we should.
I'm going to, I don't know what, I'm very sorry that I introduced auto for you. There is no auto for you, okay? You are not going to use auto. You are not going to say auto from this point on, including your final exam. If you use auto in your final exam, you are going to fail. Something with auto with this guy, I don't know. But he's doing it on purpose, just to tick me off. Okay, you understand the problem here? Yeah.
If I use reference, it's same as pointer about it.
Hold on. Okay, say it again.
If I use reference for this, is it same with pointer?
Reference? Yeah. Well, yeah, exactly. Yeah, that's a good question. So that's a good question. How about this? Can I do this? I have a new person reference, PR. Can I do this? Of course, PR can hold a reference to a S object, student object. There is no slicing happening here. But again, you can't say PR dot get GPA. No, you can't. Why? Because PR is a reference to a person, not a student, right? So you invented the same problem using the references, exact same problem using the references.
But there's no slicing, right?
There is no slicing because I did not, PR is not an object, right? It's a reference. PR is almost the same as a pointer. So Abdurrahman, you are taking pictures. That means that you are not going to watch this video?
No, I'm taking notes on them with auto reference.
That's why we don't like electronics engineers. Even a single year of study in that department makes these people like, okay. Good. Okay, so that's called slicing. I gave you the meaning of the slicing. The book does exactly the same thing using this hierarchy. There is a pet class, pet, edeb istediğiniz hayvan, and the evcil hayvan, right? And there is a dog derived from pet, okay? Pet, of course, pet should have a name, but dog has a breed, cinsi, right? So I can do exactly the same thing with this hierarchy, dog and pet, and I can run into the slicing. I don't like to call slicing as a problem. Slicing is something that happens, okay? And if you like slicing to happen, then use that way. And the other way, no, you are not going to say it, okay? So I think I did the same thing here. Slicing, well, I said slicing problem, but it is not a problem actually. It is simply, slicing becomes a problem if you don't know what you are doing. Okay? So same thing. I have a dog and I have a pet. I can make this dog to pet, again, upcasting. Upcasting is okay. Downcasting, you have to be careful. You can't do that, direct downcasting, you can't. Okay, so as I don't want to say problem, maybe slicing with the between quotes, slicing problem.
Does it
Good.
gives error? Segmentation form error.
No, you can do the assignment, no problem. No problem. What did I say? It is okay to make this assignment. Well, what happens when you do the assignment? Okay, this Ali is copied here, TJK is copied there, but there is no place to copy GPA and student, so it is not copied. No segmentation faults, no compiler errors at this position. Simply you lose some information from your derived class. Because remember, this is the base class, this is the most generic, this is the most generic type. There are extra features in it, okay? You cannot fit all those extra features inside an object of this base class. Slicing is this, okay? So test these using pointers and the reference and etc. What else? Yeah, it says slicing problem fix, but I wouldn't call it fix, but I would say this. Okay, I can do, okay, let's, again, exact same thing. Is a relationship pointer pet to pointer dog to pointer pet, okay? Then I can get the dog's name. I can get the dog's breed. I can get the pet's name, but I can't get the pet's breed because pet doesn't have a breed data member. Well, even though it is pointing to the dog object, it doesn't have it. Okay, good. We talked about this, and we talked about virtual destructors. Good policy for all destructors to be virtual. Always start writing your classes. This is a very nice line. Always keep this in mind. Okay? Right? I mean, if you don't need a destructor in your base class, okay, then write it this way. Virtual destructor employee default. By the way, what did I say? If your class doesn't need the big three, right, either put a comment saying that this class doesn't need the big three, or write each of those big three functions like the copy constructor, assignment, and the destructor, and write equal to either default or well, don't delete is not good, default, right? So do the same thing for the copy constructor and the assignment operator, so that you are telling everybody that I am doing this on purpose, or you can do it in a comment. Okay, good. So let me continue on this casting. We talked about this. Okay, downcasting. Downcasting really done due to pitfalls. I don't agree with this. No, we do downcasting whenever we need to do class specific programming. Okay, let me go to, remember what I showed you at the beginning of this chapter, this Windows programming thing. Okay, close all, remember this close all function. What does close all function do? In a vector in the operating system, there is a vector of pointers of applications, right? On this computer, I am running 200 applications at the same time. So my vector will have 200 pointers. Before shutting down my computer, would I have 3 minutes? Maybe no, I shouldn't risk it. Where is my cheap Chinese power? Okay. No bars today? Good. Okay, so this will close all the windows, right? Open windows. If I like to say close all the windows other than the calculator, what am I gonna do? I need the test, okay? Just dynamic cast this application. If dynamic cast, okay, to calculator pointer my app. If this is not null pointer, null ptr. Well, I think, let me do this. It means what? If I can convert this pointer to a calculator pointer, it's going to give me a null pointer, right? If I can convert it, then it's a calculator. If I cannot convert it, then it's going to be a null pointer. If it is null pointer, then close that application. So I wrote what? I wrote a derived class specific code in there. So what I'm saying is that close all the application other than the calculator application, right? So if I go to the book, slide again, 43, it says, okay, Downcasting rarely done due to pitfalls. No, it is not true. I don't like the statement. No, it is done a lot, but only you should be careful about this dynamic casting. Okay, you should be careful about dynamic casting or type ID thing. It is not as straightforward as either relationship or upcasting. That's what I'm saying. Okay. I like to show you one figure about this internal workings of the virtual functions. Okay, question for you. How would you implement these virtual functions if you didn't have the polymorphism supported directly by the compiler? As a C programmer, let's say you have the inheritance and everything, but you don't have the polymorphism. How would you do that? Idea is using virtual function tables. So each class would have a table of functions, function pointers, right? Remember what I did here? Remember what I did here? It's gone. Oh, well, it is there. Okay, let me open it again. Compiler Explorer. Okay. This class has two virtual functions. Right? This class has two virtual functions, function 1 and function 2. So these are virtual. So I am going to make a table of function pointers, just two of them. Okay, and I am going to keep that table somewhere in my memory, like here. Okay, this is the table for the virtual functions for class ABC. Oh, this is ABC, this is ABCD, right? Okay, so I will have both of them, and whenever I derive a new class from the base class, I am going to either use exactly the same table if I did not override them. If I override them, I am going to change the pointer definition for that function. Let's remove, for example, this function 2. Let's see what happens if I remove it. Yeah, I removed it. Okay, and let's go there. This is ABC, this is ABCD. See, did you see the difference? Say yes. See, this one is function ABC function 2, right? This one is ABCD function 1. So in this table, virtual function table of ABCD, for the function 2, I am using the function 2 of the base class, ABC function 2, right? Each one has a table of pointers, but their content might be different. In this case, one of them is the same, the other one is different. If I remove this one, tell me what's going to happen. If I remove this one, what am I going to see on the right side?
Only the ABC functions.
Line 49 will be ABC function 1, right? This one, there will be not DD, okay? Let me erase it. It's compiling and line 40 ABC, here it is, okay? It changed because, yeah, the number of lines changed because I removed the function. See, this one is same as, so the ABCD virtual function table is same as the ABC virtual function table because I didn't change anything. It is, they are using exactly the same thing. I wonder if I make this all three, they are going to share the same table. Well, this is to see what happened. Since I am not calling anything, it just, I mean, main doesn't do anything. Since I did not call anything useful, say that it is as good as not running anything. So don't optimize it. While you're trying to learn stuff, don't optimize anything. Okay, good. So I guess that will be it for today, and I think that will be it for the virtual functions and the polymorphism. Again, important polymorphism. Next week I will start talking about templates.